Good afternoon. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and today's topic, I'm going to talk about epidemiology. So, the title of this afternoon's video is Epidemiology 101. The title of today's video is Epidemiology 101. Now, the reason why I want to touch on today's subject is because epidemiology is a health science. And right now, we're going through COVID-19 or the coronavirus. Now, when we talk about epidemiology, the word epidemiology means the study of what's amongst the people, roughly translated from the Greek prefix epi, which means among or upon, or demos, which is the people, or logos is the study. Although we think of it in terms of human population, there are areas of epidemiology today for zoology, botany, and other biosciences where disease affects a population's health or mortality. It can be argued that modern epidemiology has the roots in biology and zoology, where some of the earliest instances of diseases or the study of diseases began. Today, it is the forefront of public health policy, the fight against species threatened by disease, and in driving better quality of life for people of all ages across the world. That being said, what is epidemiology? Well, epidemiology is the branch of medical science concerned with the spread and nature of infection and disease. Of course, we're dealing with COVID-19. It basically examines diseases before it reaches or while it is at epidemic or pandemic stage. Again, COVID is an example. Rather than analyzing or studying the structure, evolution, and genetics of a disease in the bacteria or virus that causes it, an area of study known as pathology, epidemiology examines how diseases or conditions exist, spread, or survive in a given population. Now, epidemiology might look at why a condition is prevalent in one population and not another, and the potential risk that condition spreading. Epidemiology is fundamental to understanding of how diseases spread, waterborne or airborne. It works alongside of pathology and other branches of medical science in understanding why a condition, including contagious diseases, but not exclusively so, is in one geographical area and not another, and what risk factors might lead it to spread. Also, they might seek to understand the cause of why a condition has not spread and appears unlikely to do so. Sometimes there are geographical or social barriers to disease, so understanding these can be fundamental to preventing the spread of a disease. Now, when an outbreak is identified, an epidemiologist may ask some of the following questions. What are the infection rates of this disease? Why are the infection rates of this disease basically higher than normal? Why are the infection rates of the disease higher than normal in this specific location? What is the potential for this disease to spread? Why are the wider implications of its spreading? What are the likely causes of this outbreak, epidemic or pandemic? What treatments are available? What can we do now to slow it down? What are known effective short-term and long-term strategies? See, epidemiology studies the rates of infectious diseases and also those with an environmental cause such as toxic spillage, food-based diseases such as food poisoning or water contamination, and localized air and water pollution. Today, it is not solely about infectious diseases, but it's also about biological, social, and environmental diseases. Now, some epidemiologists study instances of domestic violence, addiction, or mental illness, for example, to attempt to understand their causes and effects. This means that other social diseases such as suicide rates, substance abuse, and other non disease related conditions are also of interest to some types of epidemiologists. These conditions can be epidemic as well, although not with the typical biological causes. See, epidemiology is more about statistical analysis of distribution, looking for patterns and working out causes of a condition. It is more about examining trends than it is about the medical aspects of a condition, although this does play a part. Now, within epidemiology, there are areas because epidemiology is a very broad subject. Although people who work outside of medical science might think that they study the spread of infectious diseases only, they may examine rates of non infectious conditions. Professionals may work in roles concerning some of the following: etiology, which is a science. It's the study of the cause or the origin of an outbreak, epidemic, or pandemic. This can be medical or environmental or have other causes. For example, people who work in this area might attempt to understand why some areas have higher rates of mental illness, cancer, or alcoholism. Then there's the study of transmission. How and if a medical condition is transmitted from one patient to another or has another cause. Again, when we talk about transmission, it's how a medical condition is transferred from patient to patient or has another cause. It is contagious or does it have another cause, for example, food poisoning. Then we talk about outbreak investigation, the general detective work and process of examining everything related to the cause of an outbreak. Epidemiology is the medical science with all methods and tools that entails. Now we have disease surveillance, monitoring outbreaks of disease or conditioning, examining such things such as seasonal trend, regional instances, or other criteria that aids in medical planning and prevention. They are concerned with collective health rather than individual health. Then we talk about forensic epidemiology. It's a subdiscipline that basically bridges the gap between medical and criminal investigation and between examination of the individual of a patient and cause of death. Then there's biomonitoring, the examination of the body burden of a living organism. The area is basically a science or area of study that typically looks at the digestive tracts and blood system. An epidemiologist who engages in biomonitoring work, they may look at substances like urine, blood, bile, semen, and other body fluids to determine a cause of illness or health. Now, what is the difference between, for the most part, of outbreak, epidemic, and pandemic? Now, this is very big because we're going through that with COVID. Because epidemiologists are concerned with the spread of conditions, including but not limited to infectious diseases. So the words outbreak, epidemic, and pandemic are used interchangeably in the media and in common language. However, they have different meanings in a scientific context. So when we talk about an outbreak, it's simply when a disease occurrence is given population, usually a small area, is higher than what would be considered normal parameters or a geographical location that is experiencing the condition for the first time. A locally occurrence of food poisoning would be considered an outbreak, usually caused by customers buying the same contaminated food batch from a grocery store or from the same takeout. Then we deal with the epidemic. It's usually when a disease affects a greater number of people than is considered normal or over a wider area. It is similar to an outbreak, but the geographical zone is larger. Additionally, an epidemic is declared when a disease has spread over a geographical area where it is not typically seen. This means that it has spread from one area where it is normal to another area where it is extremely rare. Now we have a pandemic, and this is what COVID is. Like an epidemic, except the disease spread is global. Notably, pandemics include the 1918 influenza pandemic. This affected over 500 million people and killed more than the First World War. Then there's the AIDS pandemic that has been ongoing since the 1980s. Pandemics need not kill a large number of people in a short space of time, merely that they are spread across the world. Now, although it doesn't matter how much the average person uses these terms in the scientific community, the words are important for understanding the past, present, and future threats of certain conditions. So, why do we study epidemiology? Well, basically, we study it to support the health field and other fields. So, my opinion is this: if you're interested in epidemiology, take a look at zoology, botany, and biology. Because, again, when we deal with epidemiology is a medical science that concerns the spread of infection and disease. Of course, it'll examine the disease before it reaches or while it is at the epidemic or pandemic stage. Now that concludes this video on epidemiology. If you like what I just presented, please comment, share, and subscribe. Also, if you want some more controversy or red pill topics, check out the 411 Talk Zone radio show, also on YouTube. And if you really want to get more into detail, whether it's from the Mind to STEM or the 411 Talk Zone radio show, check out my Blog Talk radio show. On that show, I will introduce topics that are too strong for YouTube. The guest calling number is 215-383-5785. And if you can't find me on YouTube or Blog Talk Radio, simply check me out on Twitter and Facebook. Again, thank you for listening to this commentary of Epidemiology 101 here on the Mind of STEM channel. And on this channel, you get a daily dose of science, technology, engineering, and math. Until next time, my name is Leon Jones. You all have a wonderful and blessed afternoon.